Okay, we pretty much finished our schematic. The next thing we need to do is to move these parts onto our PCB. Now, here's our PCB, right? I can use my right mouse button and drag it around. We can see it's blank, nothing there. Here's our op amp. Now, that little asterisk right there tells me I need to save it, so I'll hit the Save All button. Now, this thing is nice. I have my schematic. I need to move it. So how do we move the parts over? Well, let's go to the Design button here, and it says Update PCB Document. I'm going to tell it Update. And here's our engineering change order. I can look at it. Here's all my parts I'm moving on. Here's all the nets, component classes, and a thing called rooms. Rooms. All right. I'm going to let it put the room on there. We'll talk about rooms. We'll eventually get rid of it in this design because we're not going to need it. But I want you to understand what they are good for. Now I can hit validate changes. See if it'll validate them all. Okay, I got green checks. It's happy with everything. Occasionally you'll validate and you'll get a red X. Probably 90% of the time, if I just hit execute, it'll execute it and you'll see the red X turn green and everything's fine. If not, most of the time it's because you're placing a part and it can't find the footprint. And it'll tell you why it's not working. So you can go in there and make sure you have the right library open or you have the part pointed to the correct footprint. So I'm going to tell it execute changes. There it goes. It's happy. I still have all green checks, right? It did the check, said yes. Now it's done. It's all green. Great. I'm going to hit close. Let me unpin the message bar here. I'll drag this over, and here are my parts. And they're all inside this room. This magenta colored box is the room. So all my parts that were on that sheet went into one room, and here they are. Now if I take a part out of the room, see it turn green. Green is Altium's way of saying there's a problem. Turns green. Put the part back in the room. I got them too close there. And it's yellow. Right, if I did this, they overlap, they're green, they're too close. So that's what it's telling me. It's looking at this and saying, hey, all your parts are in your room. I can grab the room, move all the parts at once. Not really useful for this design. Well, that's okay. We're going to look at rooms and see what they are useful for. So I'm going to highlight this and hit delete. I've now deleted my room. Now I can move my parts anywhere I want. As long as they're not too close. If they're too close, they turn green. I can move them all over. No errors. That's great. Let's just take all the parts, delete all the parts. So now I have my board again with no parts. I'm going to go back to my original design. And if I go to my projects and I right click here and I say I want to add new to my project, a schematic, and I want to save that schematic as op amp power. Now I have a new schematic here, right next to my other schematic here. So I have my op amp power and op amp. Let's do a save all. I'm going to take these parts, which are the power parts. I'm going to do a Control X, which cuts them out of there. I'm going to go here and do a Control V, which is a paste. I pasted them in there. You see I have the red squigglies because they're all question marks. They're not annotated after I move them. So I'm going to do an annotation, annotate quietly. I've re-annotated everything. I'm going to do a save all. So now I have two schematics. Here's the power section of my project, and there's my circuit. All right, we can say fit all objects. So now I have my circuit and my power. All of it, as you'll see, is still under the op amp project. So remember, it's like relational database. I can have 10 schematics if I want. They're all going to go to the same printed circuit board because they're all in the same project. So now if I come up here and I say design, update PCB, it's still going to generate rooms. I'm going to tell it validate. Oh, unknown pins. How about that? Let's see what happens when I say execute. Boop. You see how they went from red to green? Altium does this all the time. So now I've generated my two different sheets. Here's this sheet. Oh, look at that. That sheet doesn't have a room. Let's go find out why. I'm going to go back to the power section, go to project options, class generation. Rooms are not turned on. How about that? So I'm going to turn the room on. I'll go back over here. I'm just going to highlight all of this and delete it. That guy too. And we'll do that again. So in my project options in the class generation, it was not turned on to have a room. So I'm going to go back over here again and tell it, design, update. Now look, add 2 rooms. Makes a little more sense. Execute. All green, close. Now I have 2 rooms. Look at that. 1 room for each sheet. Not so useful for what we're doing here. It could be very useful in other circumstances. Now I could put a rule inside of a room, which could be like if you're inside this room, every trace has to be 30 mils wide. Anything not in the room can be any size it wants to be. And Altium will look at that and do that for you. Or what's really handy is I could have a project, say like an audio mixer board. And if you've ever gone to a concert and you see the audio guy adjusting the sound for all the musicians up there, where he's got a channel for the guitar player and a channel for guitar player's vocal and a channel for the bass player and the keyboard and his vocal. Anyway, there's a lot of channels. All those channels are repeats. I can look at that channel and say, look, there's a master gain. There's 3 tone controls, right? High, medium, low. There's a pan control, left and right and all that. So that's one channel. I can draw that channel in Altium and then tell Altium, repeat this 16 times because I want to have 16 channels, and it'll put all those parts into 16 rooms. I can then go to the rooms and say, all right, I want this room shaped like this, and I want these parts inside the room like this. And then I can go in there and say, with Altium, I want you to duplicate this room and make all the other 15 rooms look just like this room. And it will. It'll change the shape. It'll change the orientations. Even if it's routed, it will route it like that. So now all 16 rooms look the same, and they're all routed the same. You can then take your rooms and line them up like this. So that's another useful part of Altium, using rooms. And our project, not so useful. We have 1 channel, right? Power, input, output. It's not much going on here. So I'm going to highlight the room and delete it, and highlight this room and delete it. Do a save all. I'll go back to my project here and say project options, class generation, and say you don't need to generate the rooms because I don't need you. Otherwise it'll generate it every time and I have to delete it every time. So I'll do a save all. There we go. So here's my parts. Here's my op amp. That's kind of a weird footprint there, isn't it? Look at that guy. All right, so let's move some parts around. This is my B and C connector, like on the front of your oscilloscope. I can grab it with my mouse, move it around. Space bar will rotate it. Here's my input pins, right? There we go, input. I can stick my input there, take my op amp and stick it here. Now if I go back and look at my schematics, I can say, oh yeah, which capacitor goes where? C1, C2, C5, and C6. Those are the ones that are my power input. There we go, C2, C5, C1, and C6. That way I know that I want to keep these caps by the input and these two caps by my op amp. So if I look at my op amp, look at those net lines. When I get it close here, see how the net lines cross? This guy needs to route here and that guy needs to route there. That's a little harder to route the copper. But I have an option, right? I'm the engineer. I'm in control. I'm going to grab my part and rotate it. Ooh, that's a lot easier to route that way. I like that a lot better. And the reason I looked at my caps, because if I take this same C4 and come up here, oh yeah, I could just route it right there. Yeah, it'll route right there. But that's not where I want that cap. I want this cap right next to my op amp. So I'm going to place him right there. This cap is the same. I want him next to my op amp, and I don't want the traces crossed. This little resistor here is my little 50 ohm resistor that I had from my output. Let's see, R1 was my input. And put him right here. R2 was my feedback. Whoop, those are crossing, so I can do this. Now look, if I place this close, that designator's getting eaten up by that hole, so I'm going to just grab the designator and move it. No problem. Now, if you remember, when we placed the parts, I placed the 2-pin part as just a vertical 2-pin header, but I placed the 3-pin part as horizontal. See how it's drawn on there with our top overlay? The pins come up and bend over. That way I can take a connector and push it on from the side. And the schematic parts look the same, the footprint's different, so I had an option. Let me take my parts here and place these guys. And here's my caps. I might have to move things around so I have room for everything. Let's see, I might move that. This is a little bit using your right brain and we call this artwork, because I'm using my right brain to make this look good and be readable, but I still want all my parts on there. Let's see. I wonder if I move this over and move this over, if I can get this a little tighter. Always remember that when you buy circuit boards, you're paying for the amount of real estate you're using, right? The square inches. You're paying by square inches and number of holes and all that. So I want to keep that in mind as I'm working on my board. There. Well, that's not too bad. So if I highlight all my parts, I can drag them down here a little bit and do a save all. Now, that's not too bad. I have my layout on there. I'm a little worried about this footprint though. Look at that thing. Did you ever get an op amp in one of your kits that looks like that? No. Well, they do still make that part. It's usually a military spec part. They call it mil spec. It has higher tolerances. It can operate in colder temperatures, hotter temperatures. It's more resistant to higher and lower voltages, higher precision and all that, but we're not using that in our project. And when I look at this, I'm like, man, that's the wrong footprint. When you see that actual part, it looks like a little water tower you see like downtown Gainesville with a water tower. There's a round can with a bunch of legs coming out. So let's fix that. I'm going to go back to my schematic. I'm going to highlight my op amp. I'm going to go to properties. And I'm going to say, what is going on with this thing? So I can click this guy. Here's the footprint. I can say, no, that's not the footprint I want. I'm going to tell it add a footprint. And I'm going to browse my footprints. And this is all the libraries that I have open. All these different libraries. I want to find the right footprint. So I'm going to go to miscellaneous devices. I know it's an 8-pin DIP. DIP, right? They call it a DIP. And DIP stands for dual inline package. So you have inline pins and it's dual, right? 4 pins and 4 pins. So let's look for a dual inline. Let's see. Nope, that's a resistor. There's some surface mount parts and diodes. Nope. No. Oh, look at that. DIP8. DIP8. That's the package I want. So I'm going to tell it, okay, I like that package. Save. And then I need to do design, update PCB. It says modify. Change from this H08 to a DIP8. Yes, that's what I want. So it does it. It checked it. It's done. It's happy. Let's take a look. There we go. Look at that. I now have a DIP8 package. Nice. So I can actually move my parts a little bit. Let's make sure the routing looks good. Yep, that resistor routing is okay. Let's see. It might actually be better to put it just like that. It's easier to route. That cap's in the right place. Where does this cap want to be? Oh, let's see. Maybe right up there somewhere. There we go. I can move this around and tighten this up. There we go. Now look at this. These you can see holes in the board. This little resistor doesn't have any holes. See my tabs down here? It shows top layer and bottom layer. The top layer is red. That's showing me that this is red. Why is it red? It's only on the top layer. You'll see these holes, they're multi-layer. This one's only on the top. So I'm going to show you another way to view the board. If I hit my number 3 key, it kind of shows me the board in a 3D view. And if I hit, let's see if I can remember which keys it is. No. There we go. So I'm now pressing the shift key and my right mouse key. I can rotate the board around. Now if I look at this little guy right here, shift and right mouse, I can move my board around, and what do I see? Well, I see that little guy sitting on the surface. You'll see this resistor has holes, but when I flip the board over, there he is on the other side, no holes. So what I'm actually seeing here is a surface mount part. That part is mounted on the surface of the board. If I press my 2 key, I go back to my normal view. So this is called a surface mount resistor. Might actually route a little easier if I did that. This resistor sitting on the surface, just a little chip. I did that so that we could show different types of footprints, even though it's the same schematic part. I go back over here. It's this guy, right? Same schematic part, resistor, but he has a different footprint. So it's good to see that and understand what's going on. It's like, oh yeah, still resistor, different shape. They come in all different sizes. So there's my parts. Here's my input. I want you to notice that on this guy, if I highlight him and I look at the properties, it says, the comment says input, but look, the little eyeball's X'd out. So if I un-X them, I can get my comment right there. It says input. I can do the same up here. There's my little power guy. Come up here and say, oh, power input. Let's make that visible. I want to be able to see that. Put it right here. Maybe I'll put the C1 down here and make the power input visible. There we go. Now I can do that with all of these. This guy has the same thing, right? He says output. I can make it available. I can move it. There we go. Not bad. Let's save that. Now, look at the size of my board. My board is by default this big. Way more real estate than I need for this little circuit. I want you to also notice that my origin point is way down here. So if I look at the bottom of my screen, the bottom left down here, it's telling me where my mouse pointer is. So when I'm here, I'm around 0, 0. When I'm up here, I'm roughly at 1,000 mils by 1,000 mils. That's 1 inch by 1 inch. Okay, it's a little bit offset. We're going to do something about that. But first, let's change the shape of our board. I'll show you how to do that. The board shape is defined by the keep out layer. And you'll see I have a tab right over here, keep out layer. I'm going to highlight that tab. You need to do this first before you place your keep out. And then we're going to come up here and draw the keep out. So I'm going to tell it place, keep out, track. There we go. And I can zoom in here and say I want to start right there. And I want it to be how tall? Well, probably at least that tall. So where are we at here? Somewhere around here. I can look at the bottom and see I'm at 1 inch by 2.75. Of course, I know I'm offset by 1 inch. So right now I'm holding the control key and my scroll wheel so I can zoom in and out and make sure that I can fit everything here. 2.2, I'm going to go to 2.25. So I'll come over here. I'll just watch the bottom. I want to get to 2.25. Wait a second. I want this to be. This is at 1.235. So I can come over here, make sure I'm at 2.25 and 2.75. Let's see, is that big enough? Am I going to fit everything there? I should actually come back a little bit and still fit everything. So I'll double click there. Now, where am I starting at? Whoops, I'm going to stop there. Look at this. I got a little extra piece in there. I don't want that. So I'll go back to place, keep out, track. Here's where I'm starting. My X is at 3.299. That's a crazy number. I want to come down to the edge of my board. Now, where are we at? Right over here. All right. And I'll go back to the edge of my board again to where I started. I can zoom out and look at it. Yeah, that looks good. I'm going to right click to stop placing. And I've drawn a keep out. Now, to define my board shape, I need to have all those selected. So there's a couple of options. So I could select that one, hit my shift key, select this one, come down, hit my shift key, select this one. A lot of work. I'm still all about shortcuts and being efficient. So if I select one and I hit tab, ta-da, I've selected them all. That's a very useful thing. You'll see the tab used in many, many different places. So in this case, I've selected them all. I can now say design, board shape, define my board shape from those objects. Boom, look at that. There's my board. Save all, view, fit my board. All right, not bad. Now I have a board. I'm looking at this board and I'm like, geez, if I'm going to mount this in a box, how am I going to fit this in a box and make it stay in the box? I don't have any holes. So we did a save all. I'm going to go back up here. I'm going to go to my components. Let's take a look here at the ECE. Oh, there's a 3mm hole. That looks good. So I'm going to place some holes. Just 4 holes. Not connected to anything. 4 holes floating in space. I'm going to do tools, annotate schematics quietly. Yes. Save, design, update the PCB document. It's adding the holes. Execute the changes. It's happy. Now these are green because they're too close to this connector, so I could put a mounting hole over here and a mounting hole up here somewhere. No problem. Might want to move that a little bit so it's not green. There we go. Hole number 3. Get my text in here. Hole number 4. Do a save all, view, fit board. Okay, not bad. Now we have our board. We defined the shape of the board. You know how to do that now. We put mounting holes. I went back to my schematic, added the holes, updated my PCB. We fixed this footprint, right? We put the op amp on there, and then we looked at it and said, what in the world is that thing? So we fixed it. This is probably a good point to stop here because there's a lot of work up to this point. I want everybody to go ahead with their design now and see if they can update their design, move their parts to the PCB. I'm trying to grab that H4. It doesn't want me to. There we go. Update your PCB, move your parts around, play with the rooms, see how you can have a room and get rid of a room. You can move your designators around. You can see that if I put this here and this one here, I can't really tell which cap is which. Now when I grab the designator, you'll see the cap is a little bit brighter. I can tell here, but if I mass produce this, I wouldn't be able to tell. So I'm trying to be smart about placing my designator so I can tell where things are going. All right, this looks pretty good. Let's leave this here and we'll have some more to work on the next video.